All right, now we're going to take a look at graphing the reciprocal functions, cosecant, secant, cotangent, which if you have a good understanding of doing sine, cosine, tangent, these aren't so bad. They look a little goofy, but you will see a little bit of a shortcut to help you out with it. So let's start out with, you should have a handout that's got the 3 graphs for you, so take a look at your materials there. And then I'm going to go to going back to using our unit circle to kind of help us see what this graph is going to look at, and then see if we can find a little bit of a shortcut for it. So when you're looking at the cosecant, you are looking at the reciprocal of the sine function. So what I have here is I have our unit circle with all of our sine values, and we have to take the reciprocal of each of these. So the reciprocal of 1/2, well, that's going to be 2. And then square root of 2 over 2 would be 2 over the square root of 2, so that would simplify as square root of 2 over 2 then. Yeah, 2, sorry, 1 second. 2 over the square root, sorry, that would be 2 square roots of 2 over 2. My fault. So 2 square roots of 2 over 2. Why am I doing that in my head real quick? Just 2 divided by the square root of 2. So I'm rationalizing the denominator. And so that is where that is coming from. Okay. Square root of 3 over 2, that would be 2 over the square root of 3. So then simplify that, that would be 2 square roots of 3 over 3 for its secant value. And then 1, if I have 1 over 1, the reciprocal of that is 1. One thing I'm going to look at right here at 0, this would be like 0 over 1. The reciprocal of that would be undefined. So when you're looking at the cosecant of 0 radians, it is undefined at those values. As we go over into the quadrant 2 over here, it's going to be these same values, and they're all going to still be positive. So we're going to see a repeat of those same values, and then we get undefined here. So now let's just take a look at what would that look like. Now, be aware that 2 is obviously greater than 1. 2 square roots of 2 over 2 is greater than 1. 2 square roots of 3 over 3 is greater than 1. Then we have 1 here. So I'm going to go, here's my graph of 2 pi. I should really have all of this labeled out before I start the video, so sorry about that. Alright, so at 0, we're undefined. So that means, like when we were working with our tangent function, is that we are going to have an asymptote at 0 radians, okay? And then I look at 2. Well, if this is 1, maybe I'm going to actually just shimmy this down a little bit so I've got a little bit more room. Alright, so if this is positive 1 and this is negative 1, positive 2 is going to be somewhere here. If I take then 2 square roots of 2 over 2, which, gosh, why didn't I simplify that? Sorry, that should be simplified to the square root of 2 then. Alright, so that's going to put us, square root of 2 is 1 point, alright, sorry, square root of 2 is 1.41, so, you know, that's putting us, you know, if that's 2, here's 1.41, maybe somewhere right in here for pi over 4, and then when I take 2 square roots of 3 and divide that by 3, I'm at 1.5, and so then we're getting a little bit closer here. At pi over 2, then it's at 1, and then all of a sudden it starts shooting back up to those same values until we get to pi, where it becomes undefined once again. So I'm going to put in another vertical asymptote. Now when I get into quadrants, into the quadrants of 3 and 4 here, now I'm looking at negative 2 and negative square roots of 2 and negative 2 square roots of 3 over 3 and negative 1 and then the negative 2 square roots of 3 over 3, negative square root of 2 and a negative 2, all the way back up until it's undefined again. So once we hit that value of 2 pi, we're also going to have an undefined value. When I plot these points, we're going to be looking at here, you're at about -2, and then we're at negative square roots of 2, and then we're at negative square root of 2 over 3 over 3, then we're at -1, and then it starts going right back to those values. And this graph that we get has these kind of little parabola shapes to it. Okay, so it's these broken up. So I'm going to go into what the cosecant function looks like. First of all, you'll notice that it does not, the values for its range are greater than 1 or less than -1. There's nothing that's between this area of 1 and -1 because you're looking at, again, the reciprocals of all of these. Now, to kind of look at a couple different things here, first of all, for a period of your cosecant function, to make one complete cycle, just like it is for sine, your period is going to be 2 pi for your cosecant function. Now, midline, like your tangent, there technically is no midline, okay? So a midline does not exist for cosecant and secant, okay? Because you don't have a maximum and you don't have a minimum. So a midline does not exist. Same thing is going to go with an amplitude. And amplitude is also not going to exist for when you're talking about the cosecant and secant, okay? Let's see. However, you're still going to be having those values of like your vertical stretches and your vertical compressions, as well as shifting it, doing your vertical shifts. Domain is going to be all real numbers with the exception of where our vertical asymptotes are, and those are where the values of k pi, so x cannot equal k pi. So we're looking at any integer. So k equals an integer value. So you're looking at 1 pi, 2 pi, 3 pi. Those are where your vertical asymptotes are. So I guess we can throw in here that x equals k pi is where you're going to be having your vertical asymptotes. Range is going to be the values of y that are greater than or equal to +1, or y is less than or equal to -1. X-intercepts, there are none, and y-intercepts, there are none there either. Now, something unique about this function, and you might remember me saying that it's not that bad if you know how to graph sine and cosine. You're probably looking at this graph saying, like, how am I going to remember what this graph looks like? Well, if I were to think about the sine curve, starts at 0, goes to the maximum, then the midline, minimum, back to the midline. Do you see how your sine curve fits right in between those two max, or the lowest point on the top and the tallest point on the bottom? You see your sine curve fitting in there. And what's going to happen here is it's going to happen the same thing with cosine. Now, we could take all of our reciprocals here and graph it out, and that's going to give us our secant function. I'm just going to jump to here, where here is your secant function. And if you look between here, cosine, you can see there's your cosine curve. And then if I bring it to the other side, there it is, okay? So your sine and your cosine functions fit inside of here. Now, as far as our period of the secant function, that is going to be 2 pi. There is no midline and there is no amplitude for the secant. Domain is going to be all reals with the exception of where it is getting our vertical asymptotes, and that is that x cannot equal k pi over 2, and k is going to be odd integers. So you'll see at 1 pi over 2, 3 pi over 2, that's where vertical asymptotes are taking place. Our range will be y values that are less than or equal to -1, or y is greater than or equal to +1. As far as our x-intercepts are, there are none. There is, however, a y-intercept, and that is going to be at 0, 1. And our asymptotes are going to be where our domain does not exist, so when x equals k pi over 2. So once again, k is an odd integer. So before I go on to cotangent, what I want to do here is just take a minute to graph out some examples of secant and cosecant, just to kind of give you an idea. And what I like to do is I like to not even think about this being secant or cosecant yet. I like to think of it as, well, which function, sine or cosine? And secant is working with cosine. So what I do first of all is I graph actually this function as a function of cosine. And so then I start to look at the things here, because I know that, well, then the period here, we're going to take 2 pi and divide that by 4. So pi over 2 would be the period of cosine. Midline, we're not adding anything, so y will be equal to 0. Amplitude, I'm going to have 3, and there's no phase shift. So because I'm looking at cosine, now I have a midline and I have that amplitude. And I'm going to use that information to help me graph this out. So with cosine, here I know that it's going to take pi over 2. It's going to be one period, or one whole period that I'm looking for. I want to break that up into 4 equal sections, so I'm going to take 1/4 of pi over 2, which ends up giving us pi over 8. So here's pi over 8. 2 pi over 8 would be pi over 4. This would be 3 pi over 8, and then 4 pi over 8 would give us 1/2. My midline's going to be at 0, so I don't have to be too cautious about that. There's going to be my midline. And then my amplitude is going to be at 3. So that means that we are going 3 units above and -3 units below. No phase shift to worry about. So again, I'm just going to graph out what cosine would look like. And there's my cosine function. Now I need to graph out the secant. And where I see my secant taking place here is, first of all, I am going to have vertical asymptotes going through wherever my cosine function equals 0. Okay, that's where I'm going to be having those vertical asymptotes. And then the rest of the function, where I see those maximums and minimums, that's where it's going to be bouncing off. And so my graph is going to look just like I have here in the red. And so if I could nicely get rid of my little snake line here, there's your graph for the secant function here. So by graphing out the cosine first, I think that makes it a lot easier to be able to sketch out the graph of the secant. Alright, so we're going to try another one right here. So this is the cosecant, so I'm going to tell myself, well, this is working with sine then. So I'm going to treat it like a sine function. So my period would be 2 pi divided by 1/5. So that's going to give us 10 pi for the period. Again, sine, now that would have a midline, and we'd be at y equals 2. My amplitude would be 5. My phase shift here, there is none. So I'm doing all this information to help me graph out what that cosecant is going to be. Alright, so I'm going to start out with my period, which is 10 pi. 1/4 of 10 pi would be 10/4, which would be 5/2. So 5 pi over 2. This would be 10 pi over 2, which would be 5 pi. And then we'd have 15 pi over 2 would be the other value here. All right, then I know that I have a midline would be at positive 2. And I also know that I have an amplitude that would be at positive 5. So just kind of doing a little bit of labeling right here. This would be at positive 2. 5 units above that, that would put me at 7. 5 units below it would put me at negative 3. Okay? And now I have all my information to be able to graph out the sine curve. So I would start at my midline, go up to the maximum, come back through the midline, go to the, oh, this is, I'm not graphing that very well. Let's try this. Alright, so there's your sine curve. Now, where I see my sine curve crossing over my midline, that is where your vertical asymptotes are going to be for your cosecant. And then where I touch my maximums and minimums, that's where we're going to bounce off of that function. And so now if I take my eraser and I get rid of this in between here, there's your function for the cosecant. Alright, so let's go and take a look at what the cotangent function would be. Again, you're taking all those tangent values and you are taking the reciprocal of them. When you look at this cotangent function, you might say, well, doesn't that look exactly like tangent? Well, not quite. When you think about your tangent curve, tangent has your asymptotes at the multiples of pi over 2. And so you have a graph that looks like the dotted lines here. And so now, with everything being the reciprocal, now your cotangent crosses over your x-axis where your vertical asymptotes were, and where we once crossed over our x-axis, now that is where your vertical asymptotes are. So there's a slight difference that you got to be careful about here. And whereas tangent is always an increasing function, the cotangent function is always going to be a decreasing function. So notice that it's decreasing here. So the period of cotangent is still going to be 1 pi. Once again, there is no midline, there is no amplitude to it. Domain will be all real numbers with the exception of our multiples of pi. So x cannot equal k pi. So you're looking at k being any integer. So that is where your vertical asymptotes are getting put into play here. So at 1 pi, 2 pi, 3 pi, negative pi, and at 0 pi, that is where all your asymptotes are. Our range is going to include all real numbers. Our x-intercepts are going to be at the values of k pi over 2, comma 0, where k is going to be any odd integer. And the y-intercept, there is none. Okay, so there will be no y-intercept, whereas, like on the tangent curve, there is one at the origin. And our asymptotes are going to be at the values of x equals k pi. And k, once again, is any integer. So, how do you graph this one with working with tangent? Is, well, if you can graph tangent, if that's the easier one to go off of, then you're just going to kind of have to switch things around. And let's go over and we can do an example of tangent real quick. Alright, so we'll do f of x is equal to, let's do 2 cotangent, we'll do 3 3x minus 2. Okay, so now once again we're doing cotangent, so we're going to treat it like tangent. Period, we're going to take pi divided by 3, so that's going to be our period. Now technically we don't have a midline, but we do have a vertical shift, which would be going down 2 units. Amplitude, technically we don't have one. There would be a vertical stretch by 2, and then I don't have a phase shift at all. So I'm going to start out by thinking about tangent. So with tangent, I really only have to think once again of the 2 intervals, which I'm going to do 2 periods of this. Alright, so pi over 3 would be 1 period, so half of pi over 3 would be pi over 6. And so then this would be 2 pi over 6, this would be 3 pi over 6, that'd be pi over 2. 4 pi over 6 would be 2 pi over 3. Now, once again, I am going to graph tangent. So when I think about tangent, oops, for my tangent curve, I am going to have a asymptote halfway between that period. And I'm doing 2 periods here. So at pi over 6 and pi over 2, I would have my my asymptotes. Now I'm shifting everything down 2 units, so I've got to keep that in mind. So that tells me that with my tangent curve, I'm going to start at where that vertical shift took place, and tangent is an increasing function. At pi over 3, it's going to hit that line too. And so right there, there's one cycle of the tangent. And if I were to come up here and then go from here, there's 2 periods of it. So now when you are, and actually I'm going to put this as dotted to make it, because that's not the final answer. Alright, so there's your tangent. Now since we want to do cotangent, alright, so now everything kind of changes. Now your vertical asymptotes are going to happen where your tangent function crosses over. Again, I like to use that word midline, but that is where your new asymptotes are going to be taking place. And then where it was your asymptotes before, that's where it's now crossing over that midline there. So at pi over 6 and at pi over 2, that's where it's crossing over. And now your function is decreasing as it goes through those intervals. So take a look at your reciprocal, and please let me know if there's any of them that you have questions on.